Hi, my name is Brian Caffo, and welcome to this week's Ask Brian part of our weekly newsletter. So this week I'm going to answer a question about which regression to use, y given x or x given y. But before I begin, I would like to say it's a very sad Monday morning data science because our very own Sean Cross is moving on to be a superstar graduate student. He's absolutely irreplaceable, so we're very sad about it, but we're very happy about his new position. We know he'll do great, and we look forward to really seeing some great things in the future. So if you actually happen to see Sean in real life and know him, or if you happen to see him on Twitter, wish him the best. He was invaluable here. Okay. Again, sign up for the newsletter if you get a chance. Ask a question. All the links are in the video description below. Okay, so the question the person was asking was really, thinking about y given x versus x given y. Or in other words, what they really were talking about, should I fit the model y equal to beta naught plus beta 1x plus, say, epsilon, or x equal to gamma naught plus gamma 1y plus epsilon. Okay, and so, well, what would be the rationale behind doing one versus the other? So we'll talk a little bit later about the mathematics, but the real reason is, for this model, you're really thinking along that way. You're conditioning on the variability in x, and you really want to explain the variability in y. You want to think of x as the predictor and y as the outcome. If you're thinking of this model, you're really thinking along those lines. You're conditioning on the variability in y, and you're trying to explain the variability in x. You're thinking of y as the predictor and x as the outcome. And often in many problems, it very naturally works out that way so that there's a natural predictor response relationship. Okay. And so if that's the case, let's talk about what happens, to our slope estimate. So the slope estimate works out to be the correlation between x and y, okay, times the ratio of the standard deviation, sigma y hat over sigma x for beta 1 hat, and then for gamma 1 hat, it's the correlation times sigma x hat over sigma y hat. So this, I think, is very illuminating for a variety of reasons. One is it shows us how we get our units. The correlation is unit free. Then we get units of y over units of x. So beta 1 is in units of y over units of x, which is what we want because it's a slope change in y over change in x. Okay, same thing for gamma, except it's now x units over y units, which is exactly what we would hope. So you can see all the real driver of the relationship is the correlation, and then you have these ratio of the standard deviations that are almost sort of like controlling the units. You see that if you unit normalize your y's and unit normalize your x's before you begin, then these are both 1, sigma y and sigma x hat are both 1, and then your slope will actually work out to be the correlation, regardless of whether or not you regress y on x or x on y. Okay? Now, if you happen to be in a circumstance where you don't have an obvious relationship between y and x, one is the predictor and one is the outcome, well, then what you can do is just look at the correlation itself directly. Look at sigma hat, analyze that. What do you do if you have a z, a variable that you want to control for? Well, you might look at the residual of y, having z removed from y by regressing it out, and the residual of x, having z removed. Okay, and then you might look at the correlation of those two things if you don't have a response predictor relationship, but you actually happen to have some covariates that you want to control for. Okay, well, hopefully that explains, maybe some of the rationale behind most of the cases why you would want to use y as the outcome and x as the predictor, or x as the outcome and y as the predictor. There's a collection of instances called case control studies where this gets a little weird. You might want to think of an instance where you, let's say, took lung cancer and you looked at people's medical charts and looked at the ones who had lung cancer and matched them with some controls who did not have lung cancer. And say you did 50 of each. So 50 had the disease and 50 were controls. Okay. You looked backwards and saw who smoked and who didn't. Okay. Now that's a retrospective study because, and people often do that because it's hard to prospective follow people up. If you wanted to like look at people now, some smokers, some not, and follow them up until they got cancer or not, well, that would be a very hard study to conduct. Whereas looking in medical charts and looking backwards is an much easier study to conduct. And in these cases, you can often analyze case control status, even though we fixed this at 50 and 50. These are not random numbers. We fixed it so that we have 50 and 50. You can analyze them with an odds ratio model where you treat case control status as the outcome and you look at smoking status as the predictor with other control variables as well in there. And that's some well-developed methodology. If you're in that setting, that's an instance where you want to flip the X and the Y relationship. And you see people doing that in other settings, and they're basically exploiting things like Bayes' rule to do it. And if you're in that setting, you really kind of need to have seen that material before. These are well developed techniques, so that you just need to see it once. But don't do this without having at least like taken a biostats class or some class where they cover, how and when you can do this and some of the consequences. Okay. Well, that's a little bit of information about which regression to use, y given x or x given y. I just want to say again, we're going to really miss Sean. Wish him the best. And he's been the one that's been organizing these newsletters. So it's really been great. And he's done so much for us. He did Swirl. He's, kind of unheralded, did a huge chunk of the data science specialization in all of our efforts at the data science lab. Since then, he's been a major, major component. So we'll really miss Sean, and we wish him the best. All right. Well, I will see you next week.